In this video, we will continue our look at our logarithm theorems and applying those. It's incredibly important that you know how to do this because when we start solving logarithms in the next lesson, you're going to need to apply these quickly and easily. When you get to calculus, you're going to need to apply these. So it's very important. Just like when you were in Algebra 1 and you learned how to factor, and now hopefully for the most part factoring is just second nature, or applying the quadratic formula, you just plug it in, you work it out, it's just second nature. You need to be able to get to that point with these logarithm theorems because this is going to come up often. Okay, so let's look at this first one. And by the way, we'll probably split this into 2 more videos total, and I'll work several examples for my students. This would be from your homework. So number 1, evaluate 7 log base 2 of 2 cubed. Okay, there are 2 ways to do this. One is I can take this 7 multiplier in the front and move it up as an exponent, and that would be applying this theorem right here. So that would become log base 2 of 2 cubed raised to the 7th power. This 7 multiplier just came up as an exponent. And in the next step, it would look like this, log base 2 of 2 to the 21st power. And then you apply this property right here. And notice that we'll just be left with the exponent. Well, the exponent here is 21. So this equals 21. And we're done. Because log base 2 and then 2 raised to any power is just the power. Notice the pattern is the base of the logarithm is 2. The base for the exponent is the same. It's also 2. So you're just left with that value. So I want to go through why that's true one time, and then we're just going to accept it and we'll apply it throughout the rest of the lesson. So here's why it's true. Well, the definition of a logarithm says that 2 raised to what power equals 2 to the 21st power? Well, that would be 2 to the 21st power here. So you're just left with this portion right here. That's just the definition of a logarithm. That's why these 2 properties exist. So you just need to get used to accepting that if you have a logarithm with the same base as the base for your exponent, you're just left with the exponent. Right? So the other way to work it is right from the very beginning, you see the pattern of the base for the logarithm is 2, the base for the exponent is 2, so you're only left with this part right here. The result of this piece right here, forget the 7 for now, just this piece right here is just the 3. So you have 7 times this whole quantity, which we determined was 3. It's just the exponent. So 7 times 3 is 21. So right from the very start, without applying this property or this theorem right here, you could get the answer. So either way works, either way is fine. All right, let's look at 2 next. Problem 2, evaluate. Okay, by the way, evaluate, when you see that, you're expecting a numerical answer at the end. Okay, so we want to get used to spotting this pattern again. So we have a base for an exponent is 5. The base of the logarithm is 5. So that means we're only left with the remaining part. We're only left with 3 here. So this is this form right here. And notice you're just left with whatever's right here. So we're going to cross that out and we're just left with the 3. So we're going to have 8 times 3. So we're going to have 24. And that's the answer to number 2. So let's look at 3 next. Okay, 3 says expand. So when we expand, we want to go from less to more. So with our theorems, copy them down again for this problem. With our theorems, we want to go from this side to this side. So right now, what we have is log base 2 of a quantity that's multiplied together. So it looks like this right now. So we want to split that into 2 pieces and make it look like this. So it would become log base 2 of x plus 7 plus log base 2 of x minus 2. So we just took the 2 parts that were multiplied, split them, and wrote them as 2 logarithms added together. So that's it for 3. 4 is going to be very similar. It says expand, so we want to go from less stuff to more stuff. So in this case, we're dividing the argument of the logarithm. The original logarithm is dividing, so we're going to move it into subtraction. Remember in your theorems that multiplication and addition go together here, division and subtraction go together. So this one would become log base 3 of x minus log base 3 of the quantity 5 subtract y. And we'll put that argument in parentheses as well. So we just went from division to subtraction. The numerator goes here, the denominator goes here, and we're done. Make sure you always use the same base, log base 3 in this case, here and here. All right, that's it for 4. Let's move on. Okay, on number 5, we're expanding again. We'll have some additional steps here. So we're expanding. We're starting with a logarithm that has an argument that is divided. Remember, the argument is just what are you taking the logarithm of, right here in parentheses. So it would become log base 4 of x squared over, let's do that again. Log base 4 of x squared minus log base 4 of m. So the numerator goes here, denominator goes here, and we're subtracting those pieces. Now, one last thing we can apply, we have an exponent here. We can pull that in front as a multiplier to expand it even more, and that is applying this theorem right here. Notice that the exponent moves to the front as a multiplier in this last step here. So that's what we're going to do. The 2 comes in front as a multiplier, log base 4 of x minus log base 4 of m. So this 2 came right here. That was the last step. So this is the answer to number 5. It's fully expanded. Okay, 6, expand ln of this entire quantity. Remember that ln is just the natural logarithm, so no problems there. We've seen that before. So notice that originally we have an argument that has 3 factors in it. We have 4, we have x squared, and we have y to the 5th. So we're going to split those from multiplication into addition. We're going to apply this theorem right here. So when we do that, we get ln of 4 plus ln of x squared plus ln of y to the 5th. It's a good idea to put these arguments in parentheses here. So once I've done that, I can start looking for any more expanding I can do. Well, this 2 can come in front as a multiplier. This 5 can come in front here as a multiplier using this theorem. So then once we're done with that, we'll be completely done. So ln of 4 plus 2 ln of x, that 2 right here came in front as a multiplier, plus 5 ln of y. So this 5 right here came in front as the multiplier there. So that is it for number 6. All right, next here, number 8. We're condensing. So in the others, we've been expanding. Now we're going to condense. So we want to end with less stuff than we start with when we condense. So we're going to be looking at the forms this way, moving them over here to this form. That's what we're going to do. So there's more than one approach here. And by the way, this is why it's a good idea to put the arguments in parentheses. Here's what they intend for this problem. We're taking the ln of y right here. We're not taking the natural logarithm of y plus 3. This plus 3 is off to the side. Okay, so that's the way we're going to approach this problem. So I'm going to choose to handle it this way. I'm going to first handle that and condense it using this theorem right here. So the n, or the 8 that's in front, is going to come up as an exponent in this initial step here. So ln of x to the 8th. I just condensed that one part there. The 8 was in front, it came up as the exponent. All right, and then we have subtract ln of y and a plus 3 there. So next thing I'm going to do is condense these two down into one logarithm, and subtraction and division go together. So that's this theorem right here. So this is going to become the numerator, this is going to become the denominator for our condensed a natural logarithm here. So x to the 8th over y is the new argument, that whole thing, and then plus the 3 out to the side, and that will be the final condensed version for number 8. All right, I'm going to call that good for this video. I will work problems 9, 11, and 14 in another video. So I guess that will be part 3. This was part 2, so part 3 will work those 3. That's it.